Hey, Miguel and back here on the CRP, and we're going to our Outside the Cage segment as promised. I'm joined by Chad Lack, our usual host, and Chad's here to deliver some information to us on stem cells. If you want to check back on my recent podcast or my recent recording where we were asking, what are stem cells anyway? Because they're starting to pop up in the world of MMA and here on a personal level as well, as you're going to find out here. So, what's a stem cell? And Chad, of course, has some experience with this stuff. So we're going to start answering some of the questions from a basic point of view. First of all, that question will be what we lead off with. Chad, how you doing?
I'm doing pretty good, Miguel. How about yourself?
Good.
I'm sorry. I should say I'm doing well. Grammar police, bad me. No, I'm doing well, and I'm excited about this topic because it's something that I really want to cover, and I want to spread not only what I know about it from an academic standpoint and from a research standpoint, but what I know about it from a personal standpoint, which I think they always say always ignore the personal what do they call those that when people talk about it and they say, oh, go ahead and check out what people say about it. No, don't check out what people say about it. Check out what science says about it, and then go look at what people say about it after you find out what science says about it. That's just a general rule of thumb to go by. So today you and I are going to talk about this, and we're going to talk about what science says about it, and then we're going to give you some examples of real life analogies and in times that things that we've seen. Correct?
You back?
I'm here. I never left.
Okay. I said today you went here. You went today. We're gonna do, and it froze until you just came back.
Oh man!
So go ahead and take it from there. I'll have Jesus edit it out.
Okay. So here's the deal. When you look at pseudoscience, and what does pseudoscience always use? They use personal expressions from people who have actually experienced it, right? So they say, well, the proof's in the pudding. This person says that it works, and it works. And so you go out and you buy shark cartilage because it's going to fix your knees, right? And then you go, this hasn't done anything for me, and I've spent $4,000 on shark cartilage pills. So one of the main things that's very, very important as a scientist, as an academic, and just as a consumer in general, is that you always look initially at the science. And after you look at the science, then you look at the rest of it and you see whether or not the personal descriptions of what happened matches up with the science. So we're going to do that today by opening up with science first.
Yep. So take me through the basics here. What's a stem cell? Because when from a layman's term, you hear the term first. That it's a treatment. Some people get help for sicknesses or illnesses, and then you hear athletes are taking it and stuff. So what is it really? What's going on there? And then the other part that I think we can address here is that if you look into it a little bit, you'll hear that stem cells come about there's a real moral issue there, and you got the Christian right that's against them for, the embryo or so I'll let you take it from there.
Okay. So first of all, if you're a Christian or a Muslim, either one, both identify the embryo for the first 43 days, I think, in Christianity, and it's like 48 or something like that in Islam. They identify it as just water, for whatever that's worth, which is also wrong. But for whatever that's worth, they do identify it that way for the faux pas there. Let me explain the difference between what we used to know about stem cells and what we know now. So the question is, are these coming from abortions, from aborted fetuses, right? Well, the way stem cells were originally discovered was some of these aborted fetuses, and I don't know the full history behind it, but they somehow figured out that there were parts of these aborted fetuses, especially the very young ones, that had cells in them that they could study. And they simply wanted to look at it and say, here's a way, look, here is an aborted fetus. It is, the size of a pea, basically. And we want to put it under a microscope and see what it looks like, right? No different than if a woman had a miscarriage in her second, in her second or third month. So it's the size of a pea, and you put it under a microscope and you look at it and you try to figure out what you can learn about it. Well, what they figured out was there were all these cells, and they couldn't figure out, well, how does this cell know how to become this cell? So why does this cell differentiate from an eyeball or a toenail, right? Or a toe, right? Why is it a toe or an eye? And what they found was that there were cells called pluripotent stem cells, meaning they were able to become anything. They were omnipotent, really. They could become anything in the human body that was already there. In fact, you could even do intergender crosses that I know people originally did, and they put a stop to that very quickly for all kinds of ethical and moral reasons that are scarier than I even want to think about or go into. It's Joseph Mengele kind of stuff. But the deal is this: a stem cell is a cell that becomes other cells. So a stem cell is essentially a cell that is that makes your ear, or that makes a bone, or it becomes whatever it becomes, and it does that through a chemical, electrical, magnetic combination of different things, through RNA, through mitochondrial, taking the signals, unzipping them. They call them exosomes. An exosome is a signal that the RNA gets. So we almost have to break this down to, okay, let's start at a cellular level and explain to people how a cell works. Do you want to go that deep, or do you want to skip that?
Well, let me ask you if this assessment is correct. Then again, just try to break it down. So in a way, a stem cell is kind of like a pit bull or a gun, right? It's dangerous or unethical depending on whose hands it's in.
Yeah, I suppose that's a pretty good way to look at it, Miguel. Yeah, brilliant as always. Yes.
Only because because now my understanding is now the fetuses and things like that. Yes, of course, there's always going to be that discussion that needs to be had. So they move beyond that, though, right? So now
yes,
they don't need to go to those places to get the type of stem cells that they need anymore. So where are we getting stem cells now if it's not fetuses?
Oh, see, that's a great question. So here's the thing. What we discovered through all of this, and actually we discovered this because of the ban on stem cells through fetal use. We were extracting stem cells from aborted fetuses initially, or miscarriages or whatever. And there were a group of people in the United States who found that extremely unethical. And George W. Bush put a stop to it and said, no more stem cell, which, by the way, put the United States behind 8 years everyone else. There's a reason why all over the world you can get stem cells, but you can't get them in the United States right now. You can, but we'll get to that in a little bit. It's pretty limited. And that has more to do with the Christian right deciding what was going to be legislated and what was not going to be legislated, which we could talk all day about the separation of church and state. We'll stay out of that for now. What we found out, though, scientists wanted to continue to look at this, and we figured out, wait a minute, if there are stem cells here, where else are they at? And what we found was the best place to get stem cells initially was in the bone marrow of the same person. Because when you used a pluripotent stem cell to try and treat something, because it can grow into anything, it grew into everything. And what wound up happening was you had tumors. And so these tumors were problematic, and we couldn't figure out how to use them. We were like, we know these are great medicine, but how do we control them to turn them on and off? which of course goes all the way back to RNA, exosomes, and a basic cellular idea here is that inside the cell, you have this little thing floating around, and it's called DNA, and it's a spiraled ladder of it's a ladder, and the ladder spirals. RNA comes along. Our RNA is a process of unzipping the DNA. When it unzips the DNA, then a different protein can be put in there, and in so doing, change that cell to something else. So stem cells, in ways that we still don't understand completely, we're doing this. But if you put a pluripotent stem cell in without the right exosomes, which are messengers, and the right cytokines, which are messengers, if you didn't put the right message in there, then you might grow an eye on your forehead, so to speak, right?
Let me ask you this quick question. So is this stuff like your blood, like or like when you get a kidney replaced, you may go through a rejection process. So if I get stem cells that aren't from my own bone marrow, I could reject them.
That is an awesome question, and it's called immunoprivilege. That's where mesenchymal stem cells come into play. We're going to talk about immunoprivilege here in just a second. So let me separate fetus from non-fetus stem cells, and why we don't use fetuses anymore. And in fact, they're not preferred. The fetus is not preferred at all. So one of the questions that I got was, yeah, but in other countries, you got to go to another country so that they can use the fetus, right? Wrong. No one's using fetuses for stem cells anymore because it's so much easier to get mesenchymal stem cells. And when you get mesenchymal stem cells, they only become the thing that's around them through cytokines and exosomes, which are chemical signals and basically amino acids, right? So you get your amino acid block, and your amino acids are what come in and they fit into the right peg in the right rung of the DNA. When the mitochondria unzips it, moves it around, takes it over, this protein comes over, fits into it, drops it off, and cytokine goes away. The protein is in there, it zips it back up, and then it sends it out to make more of those cells, and those cells start to split and procreate on their own. So
like, okay, what is this good for though? Like, is it the kind of thing that, a common cold, it's like, hey, get some stem cells and you'll be better? Or, is it like chronic diseases? Or it's like, what about, like, my knees have been shot for 20 years.
Yeah.
Like, will they help? It's like, oh, my knees feel better. It's like, oh, I feel like I could play basketball again. That kind of thing.
Yeah.
Like,
Yes. Okay.
Youth?
That's a little trickier to. Let's leave that for another time. But let's at least address the initial question, because that gets into a deeper area of what stem cells can and can't do, and quite frankly, some of it we don't know yet.
That's my question: is what's this good for, and what's it not good for? Because I've heard it's good for, like, even things like Alzheimer's and things like that, which, like, you don't traditionally think of. Like, you think of the mind breaking down, but it's also like the person's ability, mental ability. It's not like a physical, like to me, it's changing the way I look at some of those things, I think.
Oh, okay. First of all, thoughts are physical, so no different than I reach out and I grab this cup.
Yes,
a thought is a physical process, right? It's electrochemical, and that's called an action potential. An action potential has an awful lot to do with whether a thought becomes a thought or not. And we can get to that on another occasion. Let me finish this first. Let me finish why we're using something besides fetal tissue now, so that people can understand, because that's a big one, right? Because people automatically have been turned off by this when I've talked about this through the years, because nope, that's fetal tissue, that's an abortion. Not supporting that. That's a dead baby. That's the end of the discussion. And that's it for them. Okay. I respect where they're at on that and where their values are at on that. That's their choice to think that way. The fact is they were correct. They're now wrong, because stem cells no longer come from fetal tissue, because it's so much easier to get it from adipose tissue, which comes from the umbilical cord. So you pull out the tissue. Basically, if you take an umbilical cord and you cut the ends of the umbilical cord off, and you take a scalpel and you cut the umbilical cord, down the middle, and you lay it open, sort of like if you laid a snake open, right? You cut a snake at the belly and laid it open. You'd have all this stuff in there. That's adipose, or part of it is adipose tissue. You take that adipose tissue and you pull it out of there, and then you centrifuge it and you spin it down, and you're able to separate the stem cells from the others, from the rest of it, because things separate because of weight. And of course you have to do growth factors, and there's a lot more to it than that, but I'm kind of giving you the layman's shot here so we can get through it without,
this is
100 years.
Information. I'm actually making notes.
Okay. So the next thing that happens is this. Once you get adipose tissue, you can actually mine stem cell, mesenchymal stem cells out of it. And I'm so used to calling it mesenchymal stem cells because initially that's what they were calling it 6 and 7 years ago. And now they call it mesenchymal stem cells. So pardon my French, I mess up there a little bit, but it's so a mesenchymal stem cell, there's no P in it, is mined out of the Oedipus. Okay, so you take the adipose tissue, you put it into a centrifuge, you spin it down, you sort the cells out, and then you put them in basically a petri dish, right? And when you put them in a petri dish, you start growing the cells. Okay, so you can take cells, and when you take mesenchymal stem cells and put a growth factor with them, and a growth factor is nothing more, remember, than cytokines, and they're chemical messengers, right?
So they're able to duplicate the messages in the lab.
They start to duplicate, and they duplicate very, very quickly. And the younger the cells are, the more quickly they duplicate. So let me ask you this, Miguel. If you've got bad knees and you went into a doctor's office and they said, look, we can either give you stem cells from this umbilical cord, or we can drill a hole in your leg and we can get to the bone marrow. We can pull the bone marrow out, and we can spin those down, and we can multiply your mesenchymal stem cells from there. Which would you rather do?
Yeah, it sounds like a lot more intrusive if they're going to your bone marrow and you have to be your own donor.
Yeah.
The fact is I would definitely do it if there was a benefit to it. But from what you're describing is they've gone beyond that need, and there really is no detriment. It's the same thing.
Yeah, and so remember, one of the main words that we're talking about here is immunoprivilege. And what immunoprivilege amounts to is that you can take a mesenchymal stem cell from my wife's having a baby and cutting the umbilical cord, and you can take that and you can put that into your knees, and they don't reject, because you're not what I think people misunderstand is they think that the stem cell itself is going in and replacing something, or it's attaching to something, when in fact the mesenchymal stem cells are, most of them are there for a very short period of time. That's why we injected so many in my son Soda Pop, because his brain injury is so severe that he needs them to last for a long time in order to see real improvements and build a lattice. Okay. So we're going to get to a point where we talk about, well, does it help somebody who has endometriosis, or does it help somebody who has, bone density loss and things like that? We can get to that later, but for now, let's stick to Let's stick to just kind of the simple basics. So you get the mesenchymal stem cell and the mesenchymal stem cell, sorry. And when you do that, you put that into a petri dish and you put it with another growth factor. Now, they start to triple very quickly. They double, then they triple, and then, they exponentially grow. And suddenly you have 50 million mesenchymal stem cells where you had 20,000 2 days ago. So exponentiality is a big part of this. Then you take those and you put those into another growth factor, and you can literally inject those directly into the bloodstream. Okay, so that's the basics on how it works. Now, if you would please ask me, is there any other place that we could inject these? Why not inject them directly into the site?
Yeah, and that's what I've heard, because I've heard, like, on the MMA side, I've heard of a fighter having them injected directly into their knuckles, like, for example. And then, other examples, obviously, with the knee and things like that, is something that you've heard. And then would they do something like directly inject the brain? Okay. That sounds dangerous.
We're not there yet, but I think we're closer and closer every day. The closest you can get to injecting into the brain right now is to simply go intrathecally, which means you go into the back, you get into the spinal fluid. You have to drain the same amount of spinal fluid out that you put in, because you'll have what do they call that? Leakage headaches. So, okay, you get into a car accident and you get whiplash and you hurt your neck, and suddenly you start having these horrible headaches, which is what happened to me. So I got hit by a car a couple of years ago. I got T-boned at an intersection. Just a kid ran a stop sign, T-boned me, flipped me into the field. And in so doing, it messed up my neck. And when it did, I'm unable to train and do strenuous activity now, because what happens is I'm having not only do we have what's called post-concussion syndrome, which we'll get into that later, because that's really important for fighters, especially all athletes, but fighters in particular for our needs. But what happens is there's a leakage of the spinal fluid. And when that spinal fluid leaks, it actually causes flash headaches. When I put pressure and do things that make my neck work harder, so if I'm lifting heavy things, if I'm rolling in jiu-jitsu, if I'm wrestling, if I'm getting hit and my head's moving when I'm training, I can no longer train. I can't do any of that now. I'm hoping that once we're done with my son's treatment, that I'll be able to get some treatment as well. But it's pricey and it's not something we can afford right now. But when I'm able to finally do it and it reaches the United States, I'm going to be the first in line, because I want to patch up the cerebral spinal fluid leakage that causes me to have these headaches, which doesn't allow me to do anything strenuous. So I've gained 50 pounds based simply on the idea that I really can't do anything. Anything strenuous that I do, I get these flash headaches, and I'll literally almost fall down. I got excited at the Metallica concert a couple of months ago, started banging my head, and I had to sit down because I felt so bad. I felt like my head was going to blow up, and that's because of leakage in the cervical area of the of your back, your neck. Okay, so back to the question at hand, though. Sorry, I went on a little tangent there. What's really important to understand for people right now in this episode is that there are no longer fetal tissue being used in stem cells, because it's just not worth it. It's too much work to take a pluripotent stem cell, which all fetal tissue basically is, or most of it, and then turn that pluripotent stem cell into a tripotent. I forget the term right now. Sorry about that. I'll catch it up later. We'll try and put it in the notes or something. And then what happens is you have to keep changing that until you get it changed into a a mesenchymal stem cell. So we got away from that simply by taking it out of the adipose tissue in the umbilical cord. So there's no need for fetal tissue anymore at all. In fact, if anyone's using fetal tissue, they're doing it for what I would consider probably nefarious reasons, to try and figure out something else bizarre, who knows what, cloning. I'm not really sure what. I have a sneaking suspicion that there are countries that have probably cloned human beings by now using these techniques, actually. But anyways, back to it.
We're definitely in, futuristic 21st century type stuff there. You know what I mean?
Yes.
I did sense that we're getting close to some other sciences and things like that, and cloning and things like that. Obviously, we could save for another podcast. But sticking with stem cells here. So this to me is, I'm going to open up another moral dilemma then here, and I talked about it in one of our other podcasts, but to me, I think this is what's coming down into the sports world. At the end of the day, we're a sports podcast, right? So It's like, what happens when you have a fighter that has enjoyed extensive stem cell therapy, has had the resources to go through it and things like that, and that fighter is scheduled to fight a fighter that has never had a stem cell type of therapy to improve him, and say they're both about mid-30s and they both have about 30 fights under their resumes and stuff. So like at some point is there an unfair advantage? Is there is that a social economic advantage really at this point? Or how does that work? So I think that's part of the moral question. So here's the question as it applies to it. In your experience, and you have a very personal experience with your child going through an accident, and this to me becomes a situation where when you have a 3-year-old with a traumatic brain injury, that to me becomes number one for treatment, right? That should be, a person that has their whole life ahead of them, let them get to a position where they can exploit their potential and live a fruitful life. It's very important. So I think that would be the number one target for the treatment. But what it seems to be more of that is that it's like the Chael Sonnens of the world, who are already pretty fit and pretty prime athletes, are looking for an edge in their sport. So isn't that like a perversion of this whole thing?
Okay. I understand the argument, of course. And you could almost say, is it a PED, right? And the answer to that, of course, is no, because it's natural. Okay. And so anything natural can't be considered a PED. That's pretty much how they sort it out. So they say, I mean, look, if you can eat a chestnut if you can eat things that make you perform better, then there's nothing wrong with that. Every athlete has the ability to do that. What you're saying is look, this is, for example, it's about $30,000 to have a full treatment, not to mention travel, etc. Okay, because you can't do it here in the United States. But let's take Joe Rogan, for example, who has had stem cell treatment. He's one of the first people that I ever heard openly say he had stem cell treatment. So Joe Rogan said not only were his hips killing him, but his shoulders were so bad that he got to where he couldn't even train. He couldn't throw punches anymore because he'd done it for so long. He'd worn out cartilage that separates his shoulders and, the rotator cuff and all that stuff. So he goes to this doctor and somehow finds out about him, probably through his podcast, I'm sure, and goes to a doctor in Las Vegas that says, yes, I can do that. So the answer in the United States is, if you have bad knees, if you have a bad back, if you have a bad neck, if you have bad shoulders, if it's a tissue issue, if it's a soft tissue issue that doesn't have to do with muscle, it has to be a soft tissue issue where they can inject that, and then they site inject. And through site injection, the stem cells actually go directly in there and they start to heal that area. And they're using mesenchymal stem cells in that as well. So pretty much any other stem cell is off the table now other than mesenchymal stem cells. So that's the first thing to know. The pluripotents and the omnipotents and all that stuff is pushed to the side. We don't really use any of that anymore. And I'm sure that there's going to be a time when that comes back around and becomes a huge benefit, but it's not right now. So in the United States, if your knees are bad and you want to get your knees fixed, you contact BioAccelerator and you call me, write us a letter, whatever you want to do, shoot us an email, a message, whatever you want to do, text me, 765-210-0123, and I will help you get plugged into the system, and you don't have to go through the painful, horrific exchange of things that get your knees fixed. So a famous incident is Dana White's incident. Dana White, a lot of people didn't know this, but he was basically deaf in one ear. And what it really was is that he had something like tinnitus, which is a ringing in the ear, for his entire life. And it was only in one ear, but it was so severe that he couldn't hear. Okay, so he went down to Colombia, where we go to Torres through BioAccelerator, and he had one injection. He came back the next day, and they said, "How are you feeling?" And he said, "I don't need any more. I'm done. I'm good." And they said, "No, we have to continue to give you the rest of your injections." And he said, "No, really, it's gone. For the first time in my life, I can hear perfectly out of both of my ears." That was one day. Now that's Dana White's story, not mine. Okay, so you can check him out on it. He'll tell you all about it. It's pretty amazing. Chael Sonnen used BioAccelerator also and went to Colombia, Medellin, Colombia, which is it's the Medellin, Colombia, where the facility is located at, where we receive treatment, is called the Golden Road because it's the Beverly Hills of Colombia. And so, we couldn't afford to buy a shoestring there. So, pack accordingly. But Chael went down, and he really did it just to see if he got any benefits out of it. And what he basically said was, I didn't feel anything immediately, but over time I felt better and better and better. So to answer your question in a long-winded roundabout way, Chael Sonnen just retired last night from Bellator. 2 years ago, he got his first injection of stem cells. So is that what brought him back into the cage? I don't know. It'd be nice to get Chael on the show and ask him about that. I know you have a direct connection with Chael through Bodog, and maybe Chael will reach out to us and we can talk about it sometime with him. That'd be awesome. The guy clearly has done well. He looks for his age and for the amount of training he says he doesn't do. He's been pretty successful. He's had his ups and downs, obviously, and he lost last night to a really tough opponent who, in my opinion, is, just kind of outclassed Chael because he's still very active, and Chael's more, Chael's getting paid. He's looking for podcaster. He's a podcaster he podcasted last night before the fight. He podcasted with TJ Dillashaw about Dillashaw's PEDs. Speaking of PEDs. Right. So to answer your question, no. So to answer your question, no, stem cells are not the same as PEDs because A, they're natural. B, you can get them from your own body. Now you might make the argument, in order for them to be legally used on an athlete who is currently competing, they have to take them out of their own body. But that starts to be, how do you police this? They can barely police what they've got now. Every day there's a new PED out there that's not on the list. Yep. Every day. So
let's get back to the stem cell theory.
Okay. So what else have you got?
Well, I understand, but there is going to be then that social economic question, because at $30,000 a pop, a guy who's working at Walmart and training at the local jiu-jitsu school, and went 5-0 on a local show and gets the UFC call, he's not going to have stem cells access, and he may be facing a guy that that has. And as you said, if you feel better over time, that may be that the cells are identifying certain spots and going and applying themselves and things like that. That's what it seems like. It's like you may have a Dana story where there's something severe that I guess they pinpoint and go right, and maybe there's change, and then over time too. That's the question. That's the fountain of youth question. Is Chael may have felt a fountain of youth type of effect. In a couple of weeks, it's like, yeah, I do feel pretty good. So all that I still think will create a moral dilemma as we go forward in the sports world. But let's talk more about like the treatments that you've seen with your child too, because it hasn't only been the brain, right? It's also been some of his motor functions and things. I saw a video exercise where he broke his own records by a considerable amount.
Yeah.
Some simple standing up exercise and things like that you go through in physical therapy.
Yes. Okay, so now that's a great question, and it's a little bit complicated. Let me start by saying that as far as let me unpack that a little bit. So as far as the PEDs are concerned and that kind of stuff, I think we're just getting started on that, like you said, and we'll see where it goes. There's going to come a time when, okay, for example, if an athlete tears his rotator cuff and he has to go in and have surgery, like Dominic Cruz did, or he tore his knee, okay, and he had to go in and have surgery. What would have happened if he could have, if he would have known about stem cells and went down and had the stem cells done instead? Well, here's the next step that the United States will take. When insurance is able to start covering this, and it's FDA approved and all that, then it's going to change the whole direction of how that works, because they're going to use stem cells with surgery. The reason that they want to block stem cells right now is because they don't have a way to monetize on it. And they're going, well, we've got all these surgeons who've spent their entire lives learning to be surgeons. And now you're telling me that he can inject this into this guy's leg and his knee is better, so he doesn't have to tear the cartilage out, put new cartilage in, put cadavers in, all that stuff. Didn't have to do that stuff anymore. So there's a conspiracy in that we can talk about at some other time. As far as my son is concerned, though, and okay, so Soda Pop was in an accident with my mother. She pulled out to see around some weeds, and she got T-boned in her van. She was killed instantly, and Soda suffered a massive traumatic brain injury. Without everything being perfectly in place, he would have died in multitudes of different times throughout this whole thing. We were in the hospital with him for many, many months. And then we were told before we left the hospital that he would lay on his back and drool and stare at the ceiling, and that we needed to make him a ward of the state because we couldn't take care of him. Well, we immediately took him home. That was the last day we were in the hospital, and we got busy working on it. My wife, Andrea Thompson, is a superhero. So we got busy working on that. And in so doing, we started to prove to doctors, for example, here's the perfect case. You were talking about that he stood up for the first time in one try. So think about all of the things what you asked, what your question was does it affect the brain, or does it affect the ankle, or is it the hand? How does it know what to affect? Well, the answer is yes, all of the above. So mesenchymal stem cells go towards inflammation. And inflammation happens anytime there's overuse or use that makes it hard and makes the body work harder than it should. So the way that you get mesenchymal stem cells to work perfectly and to really tune them in is to use novel approaches. So we took him back to his therapy for his first round of therapy since we got back from Colombia, because we took a week off, we reacclimated, we let him rest. There's, it was a really big thing for him. He's 12 years old. He was gone for 10 days. He'd never been out of the country before. There were a lot of different things that really wore him out. He was kind of exhausted. Then suddenly, around the third day home, he went from he would when he would get tired. So you would do whatever all day that you're doing, running around, playing in the yard, and doing things that he does. And then around 6 o'clock, he would start to look like, he would go from looking like this to looking like this. And he no longer does that. When he's tired, he looks like this. He'll say, "I'm tired." And I'll say, "What's that?" And he'll say, "I am tired." And so you can see that on the Soda Pop and Dadillac speech show. And so you can watch his speech come along, because his speech is a huge part of what we're trying to do here. So to get back to that, we take him so we start noticing things immediately. And there are other things as well we can talk about another time. But we take him to his first therapy a week after we get home. And one of the things that he's supposed to do is get off of the floor. Now, I want you to think for just a second. If you're sitting on the floor and you have to stand up off of the floor without grabbing something and pulling yourself up, how do you do it? Most people, they turn over onto their knee, they push off of their hand, and they stand up. That's the basic way that human beings stand up off the floor. Well, Soda doesn't have a left hand to do that with, because it's paralyzed. And he has hemiparalysis, which means the entire left side of his body is paralyzed. So his left leg is also paralyzed. And so he has swinging gait. When you watch Matt Hughes, you'll notice that his left side also has a swinging gait. It looks kind of like he's got a stiff leg. Well, Soda's leg is starting to not be so stiff all of a sudden. And his first time back, they said, "Okay, let's go through this and let's see how many times it takes you to do this to start our base again. And then we'll see how to measure from there." So he does that. He leans over, and you can see this on the video. And you're going to put the video on here, right, Miguel?
Yep.
Okay. So you'll see him. He puts his right hand down and he just stands up. And in the background, you'll hear the therapist say, "I have goosebumps all over my body." And usually it would take him 5 or 6 times of starting to stand up, face planting. You'll see he's on mats when he does it, because we have to be careful. We have to catch him. If he's outside and he tries to stand up, I make him stand up anyway. We're rough on him. I mean, we've had a lot of people say, you're too hard on that kid. And I say, if we're not hard on that kid, then he doesn't do what he does. He lays in bed and drools. And so, yeah, we're hard on him, and we have to be. And there's nothing we can do about that. And I'm unapologetic. So he stood up on the first try. They did it again. He stood up on the first try again. If you look at the next video, it shows him doing what they call the proposal, where he gets on one knee and he holds his hand up like this, like he's proposing, right? His old record before stem cell treatment, and keep in mind, this is a week after we got back, 7 days. His old record was about 4 seconds that he could stay in that position, one knee up, one knee down. So right foot flat on the ground, left knee on the ground, foot behind his left knee, and he's standing like this. Of course, his left arm kind of stays like this, and he stands like this and looks straight forward. He did it for 30 seconds, and I think he probably could have done it for 60, if the truth be told. Absolutely shattering what the old goal was. We'll put that video on here as well. You can also catch it on our Facebook. We put everything on the CageRagePodcast.com, the Cage Rage Podcast on YouTube, the Cage Rage Podcast on Facebook. So you can catch it on any of those as well. Go to YouTube and subscribe. That's the best way you can help me and my wife help my son recover. You can go to YouTube and you can subscribe right now while you're watching this so that you can help him recover. That's the biggest thing you can do. The second biggest thing you can do is you can share this. Share it with every single person you know. The third thing you can do is you can call me. You can contact me. You can ask me questions. You can ask Miguel questions. And we can help you get plugged into this system where you can get help, where you can help. People with ALS are having miraculous results with this, Miguel. I can't wait when we go back down, the people from Texas that are going to be there. I don't want to develop, I don't want to divulge people's names, but nonetheless, I hope they're down there when we're down there. They're supposed to be, because the last time we were down there, his brother was bent over in his wheelchair and he drooled, but he could use his phone with one thumb and text. And he said, I love the UFC. I'm going to check out your channel. So how are you doing out there, brother? I hope you're doing great. I know you're getting better every day, man. We're cheering for you. We're pulling for you all the way.
Yep.
His wife was a physician, by the way, just to add to it.
Yeah, I mean, it's something that we could talk forever on the subject. I've learned a ton. I've gotten a lot of questions answered for me. I appreciate you getting into the science of it. I appreciate too you breaking it down like with real talk too a lot of the way through. So I think I have a much better understanding of where this thing could go, and we can keep doing podcasts on the stem cells and the treatments there. Obviously, I have a million more questions, but we should cut it off right now.
Yeah.
And, get that video included in this one and get it up on the page. And as Chad requested, everybody, please love us and subscribe us. It's the best thing you can do to help Soda pop out.
Hey, don't let me forget, the next time we do this on our next stage, I want to tell you about intrathecal stem cell injection and how that's going to help his eye and how we are literally going to make the blind see. So that's next time. Tune in next time for that one.
And a little more of the real talk for, I guess, what'll be Stem Cells 201. But you mentioned tumors and things like that. I do want to ask you, you got to know some stories about stem cells gone wrong or rumors or things like that. I think we should put some of those out there too, so that that they're on the table as well. So
I think that's fair. But let me cut you off right there on that before we go any further. Mesenchymal stem cells do not cause tumors. Period. They can't, because they only tell other cells what to do through cytokines and messengers.
I have some more basic questions that we'll go down that path a little bit on our next podcast. Though this has been Stem Cells 101. I needed the refresh, not even a refresher. I needed the inundation of information so that we can at least move forward in a cogent manner here on the podcast. And I appreciate Chad's time. I hope everybody who's joined us here has learned something, or at the very least can add something in the comments. I'm Miguel for the CRP. That's Chad. Chad Lacko. Hit like and subscribe.